Today, we're diving into a piece of technology that's, well, it's small enough to fit on your fingertip, but powerful enough to completely change the future of medicine. We are talking about electrochemical biosensors. This is the tech that can find tiny clues about a disease hidden in just a single drop of fluid. Okay, let's get into it. I mean, that sounds like something straight out of science fiction, right? But this is the exact promise of the technology we're looking at today, the ability to get instant, accurate, and super cheap diagnostic results from a tiny, tiny sample. And this isn't just about making things easier, it's about saving lives by catching diseases earlier than we ever thought possible. So, in this explainer, we're going to break down exactly how this all works. First, we'll get into the science of how these things actually detect a disease. Then we'll see how these incredible microscopic tools are built, and finally, we'll zoom out and look at the massive global market that's pushing this healthcare revolution forward. Right, so how in the world does a tiny sensor listen for the chemical whispers of a disease? Well, it all comes down to one simple, brilliant idea: translating a biological event into a language that computers can understand, an electrical signal. At its very core, an electrochemical biosensor is a translator. It's a bridge. See, on one side, you've got the super complex world of biology, all the proteins and DNA that signal if we're healthy or sick. And on the other side, you've got the digital world of electronics. The biosensor is that critical link that connects the two. Okay, so here's how that translation actually happens. The best way to think about it is like a super specific lock and key. First, you put a sample, say a drop of saliva, onto the sensor. Now, if a specific disease marker, that's our key, is in that sample, it will find and bind to a custom-designed bioreceptor on the sensor's surface. That's our lock. This perfect fit is the magic moment. It triggers the transducer, creating a tiny electrical change, which is then amplified and displayed as a clear, easy-to-read result. And let's look at a real-world example here. Now, I know this slide looks a little complex, but it shows this exact lock and key process for detecting a cancer biomarker called CEA. Up in the top left, you see the lock. That's the antibody, just waiting on the sensor. When a sample with the CEA biomarker, our key, is added, they snap together. All the other steps you see are basically adding other nanoparticles that act like tiny signal boosters, making the signal louder and clearer. The final step on the bottom right is the sensor measuring that electrical signal, and the amount of signal is directly tied to how much of the cancer marker is there. It's this beautiful, precise chemical dance, all happening on a microscopic stage. And there isn't just one way to listen for that signal. Different biosensors measure different electrical properties. Some are amperometric, meaning they measure the flow of electricity, or the current. Others are potentiometric. They measure the electrical pressure, or voltage. And some are impedimometric. They measure how much the surface is resisting an electrical current. Each method has its own strengths, which makes this technology incredibly versatile for detecting a huge range of diseases. So, we've covered the how they work part, but how do you actually build one of these incredible little devices? The answer is really at the intersection of biology, chemistry, and some seriously cool nanotechnology. The ingredients list for a modern biosensor is pretty wild. It's straight out of a futuristic material science lab. We're talking about things like graphene and carbon nanotubes, which are amazing at conducting electricity. Tiny metal nanoparticles, like gold, are often used to anchor the biological parts. And then, of course, you have the bioreceptors themselves, those custom-built antibodies or bits of DNA that act as our lock. And this right here is one of the most revolutionary things about this tech. You might think building something this advanced requires a billion-dollar factory, but get this. Many of these sensors can be mass-produced using screen printing. Yeah, the same basic method used to print graphics on t-shirts. By printing conductive inks onto cheap, flexible stuff like paper, we can create millions of disposable, low-cost diagnostic tools that can be used anywhere. It's amazing. So when you combine that kind of high-tech performance with super low-cost manufacturing, well, you get an explosive market. This isn't just some science experiment anymore. It's a rapidly growing, multi-billion-dollar industry that is already changing the face of healthcare. Just look at the numbers. As of right now, in 2024, the global market for these devices is already worth over $18 billion. That's a huge sign that these things aren't just useful, they're essential in hospitals, clinics, and even our homes. But it's not even close to stopping there. The market is projected to almost double in the next decade or so, hitting over $33 billion by 2035. That kind of staggering growth tells you one thing. We are at the very beginning of the biosensor revolution. So where is all this happening? Right now, North America is leading the charge, making up almost half of the entire global market. That's thanks to huge investments and advanced healthcare systems. But you've got to keep an eye on the Asia-Pacific region. It's the fastest growing market out there, as the demand for affordable and easy-to-access healthcare just skyrockets. So what's fueling all this growth? Really, it's a perfect storm of global trends. First, you've got the rising tide of chronic diseases like diabetes and cancer. In fact, the constant need for diabetes monitoring is what made the simple glucose sensor, one of the types we just talked about, a household device and $1 billion product. Then add in the huge push for testing at the bedside instead of waiting for a lab, and a big shift towards medicine tailored to you, the individual. It's just a recipe for explosive growth. And like this quote from our source material says, we're really just scratching the surface here. The next generation of these sensors won't just look for one thing, they'll detect complex patterns of biomarkers. And when you combine that with smart software, well, you get a diagnostic tool with almost unbelievable power. So we'll leave you with this to think about. When a tiny device can tell you more about your health from a single drop of saliva than a full lab can today, how does that change everything? What does a world of truly personal, preventative, and predictive healthcare actually look like? The answer is being engineered right now on these tiny, powerful sensors.